Is my screen visible, sir? Hello, am I audible?
Sir, it is not visible. Your screen is not visible.
Just a moment. It is now.
Yeah, it is visible now. Yes, absolutely.
Okay. So thank you, sir, for introducing me. So let's start with our today's agenda. So today we will be discussing about the various case studies what we can found in machine learning, neural network, deep learning. So what I'll be doing is I'll take it through with the learning methods and learning approach. Then I'm having 3 to 4 ready case studies with me where I will be demonstrating with you, and I'll be explaining you how exactly neural network or neural network can be applied in those case studies or in those areas we can see. So, as I always say in my every session, that only one technology cannot have a sufficient impact over the users or over the usability nowadays, if we can see. So, we need to integrate this technology with some another auxiliary or mainstream technology. Now, if we talk about machine learning, artificial intelligence, deep learning, neural networking, then recurrent neural networks, distributed neural networks, and there are a lot of things which can happening nowadays in machine learning, because machine learning is not that new technology. It is there from a decade, but because of the increases in network use, or because of the incrementation in use of variety of things, we are moving towards automation. Now, when the automation started in industry, that time in IT industry, there was a talk like we can create machines which can mimic ourselves and which can have a human like thinking. So from that deep learning or artificial intelligence get into machine learning, and nowadays we can almost see that we already succeeded in somewhat way. We are still learning a lot of things, but okay, we can achieve that complete artificial intelligence in near future. But today, what kind of artificial intelligence we are having? As I think I have already discussed it in my previous session, I think so. Otherwise, no. In our previous day's first session or the second session, an introductory talk, I have discussed it. Like, we are having three types of intelligence, not the artificial intelligence we can say right now, the intelligence in the machine. Like, first is a very basic understanding where we are having our voice assistants which are working. They are having a very limited amount of capacity to process your input, or we can say the input stream, which sounds like a more technical, right? So it is having a very limited way to process with the input stream and create the output stream, and whatever the output you will be getting, that is what the limitations they are having. So it is having its boundaries created. Beyond that, it cannot grow itself. Now, this is a very important part. When we say it grows itself, it means what? It is developing, or that machine is developing some kind of a sense where machine is evolving, like we are evolved in some areas. So similarly, machine are improvising it themselves, and they're evolving in a better way, so they can think and they can make a decisions, right? So currently, at what pace, or we can say at what stage machine is taking a decision, it is totally depend upon how you have trained that machine. So in every single day when you are talking, or once you are working on the machine learning, you always come across with training the data or the training data set. That is what the raw information or the raw data we are talking about. So that raw data is getting fed in the machine, and then machine is understanding that particular data, and out of that machine is creating something. So we cannot say consciousness right now, because if we say consciousness, then we are talking about super intelligence or super advanced artificial intelligence. But here we yet to reach that position. But still, because of the quantum computing and the research which is going on to a quantum computing, we can achieve it in some near future, maybe in some years as well. We can achieve it. So, talking about the second type of machine intelligence is what it is, a broader intelligence. So, what is a broader intelligence? So, there we have enhanced the capacity of that machine to understand what humans are willing to perform, or humans are giving a task, and based on that understanding, it is making a decision now. But at the first stage, which is a narrow intelligence stage, there what we can see that we are having a set of instructions already inserted in that voice assistance or a small assistant type of softwares or a machine, we can say, like your Google voice assistant, home automation systems, home assistant, or we can have smart talking goggles, or smart talking some kind of instrument which can gives us a alert, but it is having a very limited bandwidth and limited area to function. So there they are not, or those application or those machines are not making any decision. What they are doing, they are only expressing the decisions, so that decision is already made. So once you are talking about the voice assistant, if you ask that voice assistant, okay Google, open messages, so there is a NLP, natural language processing, or to enhance our uh, ac- accent of talking, the way of talking, and it can derive some words out of it. Because if we see that how exactly these voice assistants are working, they're actually taking this voice or audio as an input and cleansing it into a text and converting into a text, and then applying its whatever the algorithm is there to understand what was that question, and then it is giving you the answer. So similarly, NLP, natural language processing, is nowadays getting advanced in order to function in these voice assistants very well. And again, for the NLP, there are different applications as well. But these voice assistants are getting these tasks, and depending upon the instructions which are there only. So they can give you some information. Like if I ask voice assistant, okay Google, open up a messages, then automatically, not the automatically, but by giving that task, Google will open up your messages. Now, what if there are two messenger applications are installed in your smartphone or in your machine? Then it will ask you which application. So, like for example, if you are calling somebody, and if I ask my phone that, "Hey Siri, call my friend's name is Amol." So, if "Hey Siri, call Amol," and I have stored a number of Amol with a different name or something, it will try to search it in my contact list. If Siri is not getting Amol as a match, then automatically it will tell me that match not found, ask me something else. So or there will be a scenario like of error capturing I'm talking about. So there will be a scenario like if I have stored 2 3 numbers of Amol in one contact, or I'm having 2 3 different contacts, starting name is Amol. So maybe Amol Tambe, Amol Shinde, Amol Deshmukh, Amol Singh, some kind of a input there will be. So that assistant will ask us which Amol you wanted to call. Then again, we are having a habit like we can store information, or we can store profile or mobile number in phone memory or in a SIM card. So automatically these will be asking. But these are what? These are a very limited set of instructions. So if we wanted to have a decision on what we have asked, and depending upon that question, when that machine is analyzing it and creating a pathway to understand it and then predicting it, so that is what the intelligence comes. So that is what the broader intelligence is, or what we can say the machine learning is. And after that, once we are enhancing that feature and enhancing that ability to listen, ability to adopt, and ability to what we can say give attention towards the functionality of that environment and learning out of that, that means what? We are creating an adaptive mechanism where the machine is adapting the environment, understanding it, sensing it, registering it, and then applying its whatever the past knowledge is there and predicting the future task, or can give you the answer of it. So maybe once we are having robots like in space missions, we can say. So in space missions, we need to have a robust kind of application where that application itself a remedial kind of a solution for a different kinds of troubleshooting if it is required. So maybe that machine is a rover machine, or maybe that is a software fitted onto a machine or installed onto a machine, which take place of whatever the maintenance work is going on onto a international space station. So if there is something goes wrong and it needs to troubleshoot itself, it can find the fault and it can remediate that fault there itself. So that kind of a environment we are now creating. So that is what the adaptive environment it is. Or if that repair is or that fault is beyond repair, uh, then what it will do, it will adopt that situation and creates another path, or we can say another alternate solution for that particular task to get completed. So maybe there is a task to weld something, or to have a maintenance on thrusters. So in that case, that particular rover is unable to move its one arm. Then what will happen? It will try to rectify that fault. Maybe arm is jammed somewhat because of the fluids are getting inside or something, and it is not able to troubleshoot itself. So what it will do, it will stop the functionality of that arm, reduces the power which required for that kind of a troubleshooting, saving that energy, saving that power for the second arm and the legs what that rover is having, or the tires what that rover is having for doing the another task. So that is what the intelligence. So we can have these kind of environment created, these kind of adaptive environment created for this machine, and machine can evolve themselves, and machine can give a superior performance. Now, that is a debatable question. If we enhance the ability of machine to interact with humans, or looks like the human, or talks like the human, thinks like the human, then that can be a catastrophic, what we can say, replications over the human race. So that is what the debatable question is, or that is the feed for debate. But still, if we only stick towards the technology side, then it is a very good achievement for us, and still human is achieving that. And then if we manage to create a robot or a machine which exactly thinks like a machine, do the work like a machine, responds like the machine, and sometime it proves that it is superior than the humans. That machine is what the humanoid we are talking about, like. So that kind of machine if we achieve to create, then that is a super intelligence what we have achieved. So that is the main three intelligence what we can see in every phase. So talking about the learning methodologies or the learning approaches, supervised learning, unsupervised learning, and there is a reinforcement learning. So if we take examples of that, I'm taking the same illustrators or the examples for all these type of the learning, because one area can be feed for supervised, unsupervised, and reinforcement. For example, banks. Another example would be medical, the medical field, hospitals. Third example would be retail industries, or stock market or stock exchange. So these are the prominent areas where we actually look forward to have some kind of automation, totally automated environment. So if we talk about the banks, then if we take an example of supervised learning method, then for example, if we wanted to predict, like whatever the applications we received for a credit card, so I think everybody gets one or two call in a month or in a week, आपको credit card चाहिए, or there is been a chain. Now I can see in here at my city, some credit card executives are at petrol pump, and they're asking each and every customer there for taking a credit card. If you have previously owned credit card, then on that we'll give you a credit card. So that is what the marketing is all about. But we wanted to have a automated and responsive kind of application, where we can have a necessary documents, like profiling document, and on based on that, if we wanted to predict, so if in a day I'm having 10,000 applications to perform, or 1 lakh applications to process, then on that, how many will be eligible for getting the credit card, then how many will be eligible for, again we will be having some, if we are a bank, then we will be having some another scheme, like we are having platinum credit card, we are having gold credit card, we are having what points credit card, we are having cashback credit card. So there are various products are available in that credit card facility, or the credit card main product. So if we wanted to further analyze that data, if we see that, okay, by looking at the norms, out of 1 lakh, almost 80,000 people are what eligible for getting the credit card, depending upon the criteria what we have set it. So on that, if we wanted to have a further analysis, like how many will be eligible for platinum cards, how many will be for different kinds of cards, then what we can have a automation script ready. So that time we can use supervised learning, and we can feed it that particular data, and we can see that the worthiness of that particular applicant, or the applicants which have already applied for the credit card, we can see the worthiness of it, of those applications. So depending upon the all the criterias, the criterias will be our parameters. Now I yet to come on the features. We are still on the parameters, so don't get confused between parameters and features. They are similar, but they are having some difference in it. So once we are having the parameters, based on the parameters, we can say that this person is eligible and this person is not. So who are eligible now based on their eligibility features. So if we talk about, like, if a particular person's salary is above 1 lakh, then that person is entitled to get platinum credit card. But CIBIL score, if that person's CIBIL score is above 900, then definitely that person will get it. What if it is not above 900, and it is between 700 to 800, or it is between 800 to 900? So depending upon that, so that is the parameter is what? Credit score, the CIBIL score, we used to say it. The credit score is what it is, your parameter, and in that, whatever the valuation you are having, those will be your features. So that time, because that feature is a floating features you are having, now you need to extract it, and then you need to perform the analysis. So in that way, supervised learning can help you to determine the credit worthiness of that person. So similarly, if we look at the healthcare industry, then if we wanted to see that because of the COVID pandemic, there are a lot of cases which needs to be assessed, reassessed, we can say, not only the assess, reassessed. For what? For checking whether the COVID positive person, now that person is cured and they discharge it, hospital management discharge it. Now that person needs to do the test again after 15 days to check whether it is properly remediated or not, or that person is cured properly or not, or required for the readmission. So there also we can create a machine learning model where we can have parameters like respiration ratio, blood saturation, then BP, then whatever the ratios are required. I'm not known to those ratios, but if we can see those ratios or the information, and we can create a predictive analysis based on that ratio, or we can create the analysis like I'm having a historical data of 15 days, or I'm having a historical data from the day that person got admitted to that to the hospital, when that person declared as a positive person. So from that I can have a prediction in a near future, uh, how exactly that person may be getting infected again, or what will be the chances that person get readmitted to that hospital. And it is not only with the COVID, you can create it for all the patients. So once you are having a medical history of that person, you can put it into our predictive model or analysis model into it, and we can predict whether we require to readmit it or not, because some diseases are what those are, diseases called as a timely diseases. So those are the similar kind of a disease, maybe chest pain or the chest allergy. If a person get admitted for a chest allergy, and now that person is cured, and that chest allergy kind of disease is having a pattern, after 5 years again it will come. So each 5 years, that is the pattern what we observed in that patient. So we can see that the predictive analysis can see that in a near 5 years. So but depending upon the other features as well, and that's that 5 years what the other parameters are, and now what parameters are talking about that health of that patient. So depending upon that we can guess, or we can predict the readmission rates. So this will help health workers and hospitals by two ways. First, hospitals or health workers will be ready for these kind of patients, and second one, for their own profit, of course. So for that also they can analyze the data and can predict the readmission rates. Same thing can be applied for the retail, where we are having different products of the different brands, of course. Or similarly we can have like one brand having a different products, or one brand having a child brand, and in that child brand there are different products. For example, Hindustan Unilever, Parley, not the Parle is a product of a Parley, or then there are different again ITC. So now Hindustan Liver is having their sub brands, like they are having detergent, they are having soaps, they are having uh, oil, they are having even, and they are involved in foods as well. So based on that, and now what we wanted to perform is we wanted to perform an analysis based on the current sell cycle and the purchase cycle what we are having for the particular departmental store or for the particular agency. Now we wanted to predict where that agency will get into profit or not, or in a very simplest manner that profit loss will get into the timely fashion. So we need to use a regression model on it, so it will come in another type. But if you wanted to analyze it in like the way if a particular set of customers, so based on the customer's requirement, need, habit of purchasing, the way of purchasing, spending habits, the spending capacity, can these two products will go hand in hand. Now, if you see this impact on the real time, now you can see some advertisements like toothbrush advertisement. There are two different brands. Maybe, for example, I'm not competing them. For example, there is a Colgate and there is a Pepsodent. So now, if you can see, directly they are saying that Colgate is better than Pepsodent, and they're showing Pepsodent directly on the TV ad. And other hand, Pepsodent's ad, you can see that Pepsodent and Colgate, so that they are directly moving that. So what they are doing is they are creating uh, what we can say customer engagement, where they can analyze that data and can predict, or we can get that data and we can predict how many customers are there who usually buys a Colgate's product or who usually buy for Pepsodent product. And then we can have that data, and we can see that if we wanted to pair some two products in the future for creating kind of a offer, then what will be the best suited offer. So there also you can use the supervised learning. And for making the profit and loss, you can either use reinforcement. So that is the most convenient way to understand why reinforcement. In that, if you use deep learning, and if you are having a forward feed mechanism, there you can continuously feed data of the recent or ongoing sell and ongoing purchase. Based on that, you can definitely train your model, and that model can be a very effective and efficient to predict whether this particular store will have profit from this particular product or not. It can be drilled down to the product level, or it can be on the higher level, that collectively our model can predict whether product whether that store, maybe let's take example of Big Bazaar. So if Big Bazaar will be in profit or not, so based on that we can have a prediction. And these predictions are very important in these cases, because these owners, or yeah, retail chain owners, are very keen to know whether they will be in profit or in loss. Similarly, if we go with the unsupervised learning, all these kind of examples can be fitted in unsupervised. But if you really wanted to predict what will be the next move of that player, once you're seeing a cricket match, or like it is a very common example in India. If there is a live match going on, then our all family members are watching it, and we are doing commentaries like, hey, you need to hit ball like this, you need to throw that ball like this, you need to catch it. Or once a batsman tolls a shot, then that batsman now that batsman is going to out, as it is not going as a six. So what we are doing, we are predicting the moves. So instead of we do it, if we ask our machine to do it, so what we need to perform is we need to feed that machine with the equivalent data of the other players, and then we need to train it for that particular player. So if I am a cricketer, then my machine will get all the cricketers data, means whatever the feasible data we can have, the playing segment, then how I'm playing it, what was my pace, and all those, everything will be fed on that. And then machine will predict whether in near match I'll be able to grab the score or not, or I'll get out after 5 overs, or in the 5 balls in, or at on the zero. So depending upon that, we can predict the moves. Or on the live thing, if you wanted to put it in this scenario, we wanted to put in a robot, or you are having industrial robots who do assembly task on the assembly line. If you wanted to give that attention to it, or if you wanted to give that kind of a focus on it, so those robots will understand what kind of a moves will be there of that particular product. And it can be, or in our space example, so it can predict itself what will be the possible solution for that particular damage, and can that rover remediate itself, and can save a precious amount of fuel and the energy what it is required for repairing on that. So depending upon that kind of a decision now we can make, right? So that is what the model we can create. And here in a reinforcement learning, if we can see that, if we talk about the banking industry, and if we wanted to see that whether a particular bank will have a profit or not, or whether the particular offer will go as a best offer or not, depending upon the feeds what we are getting. So that will be your perfect analogy for reinforcement learning. Just give me a 2 minutes. I'll just get a water.
Yes, sir, sure.
Yes. Okay. Getting onto a very realistic way now. The first case what I wanted to show you is that is what the face recognition is all about. So I guess we all have already gone through with the open CV. That session is already conducted. So now you have already a bit, or you will be in a better position to understand how exactly the facial recognition work, or how the computer understands a particular face and how we can manipulate it. Now, here, how we can use this open CV in a real life scenario. Uh, Imagine like if you are asked, as you are a developer and you asked to create a application where you can have input from audio or from video or from audio video file, and you wanted to extract some information out of it. Now information can be, now this kind of a scenario will be best suited in a law enforcement or in different categories also. So maybe if we go ahead with that example, because we recently did one POC, that is proof of concept for one of the agency, where they have asked us to create an application which can use machine learning, and it needs to detect a particular criminal's face from that inputted video. And the condition was that video needs to be captured from CCTV directly, the live footage, or it can be captured through a local video file. So maybe there is a recorded file available so on that, and it needs to be matched with the input video or input file what they are giving to us. So their main intention was the wanted criminals, they wanted to search for them. So maybe there is a wanted criminal, and they are having that criminal's photo, but that is not the very recent photo, that is what the 15 or 20 years back. And so you can imagine now, so from 20 years that particular criminal is wanted, and the intel is what, that criminal is still alive, and they suspected that particular criminal is at this mall, or they seen that person on airport or something. So there we can have our application, and we can analyze that feed, and we can detect whether that person is the person what we are looking or not. And it needs to be done in a real time. So that we already created, and the next version of it is that we need to detect the morphing out of it. So like there can be a morphed images, or then can be a morphed audio videos, where we need to extract that content, and we need to detect this portion is morphed, or this portion is altered, or this portion is changed, and the original portion was, if the original portion is in that footage already, or if it is deleted, then we need to take that information as well, from which frame to which frame that original content was get deleted and new content is altered. So the first part we already created using OpenCV, and we created neural path network for it. Let me just take that code for you. Yes. So there are a lot of things for this. What I'll do is, yeah. So this is just a one file. Now what we have did is we have imported a face recognition directly. As if you can see, there are some libraries which are already created for us. Those libraries we can take, and we can those are actually open source libraries, so we can change a bit, like how exactly we required. So we made necessary changes in face recognition library, and that we have imported, and then we imported the CV2. Now the code what you are looking at, this is a very simple CV2 code, OpenCV code, for taking an input and processing it against our value, uh, whatever the value we are giving. And once the value is getting matched, then it needs to identify that value, need to give a caption to that value. Now, once I'm saying a value means what? If I'm giving my image as a input, and whatever the video I'm right now having, that will be my input stream on which I wanted to do the manipulation. So once my face is detected in every single frames of that particular video input, then it needs to identify. But here is the catch: it need not to stop that video, or if it is a live stream, then it needs to be analyzed in that way, in a real time. So we have to work with the frames. So now this example is not with the live capture. So this for this example, or so this demonstration, I'll be using a local file. So but the idea is same. So what we will be doing, we will be taking our local file, we will be checking the codecs of that file. So every audio video and audio video will have a encoding format and decoding format. So those we call it as a codecs. So we need to identify the codecs, then we need to slice that video into a small pieces, or in a frames, and then we need to check whether a particular face what we have taken it as an image, the input image, that is getting matched with every frame or not. And if the match is found, then we need to mark that frame. After marking that frame, we need to draw a rectangle on that frame, or maybe any shape. Here I'm using rectangular, but you can use a rectangle or circle or oval or anything you want. And then we need to give a caption as well. So once we are saying that caption, it means what? Sorry, Ox call. So caption, because maybe you are going to find a one criminal and there are five criminals roaming around in that same video, and that also you wanted to capture. So you can give five input images or one image with the five persons. That is also can be workable, and you need to identify all the faces simultaneously in that same feed. So for that we need to dissect it in different frames, and once a match is found, then we need to give a caption like, hey, I found Amey, hey, I found Amol, hey, I found Ankita. So that way you wanted to display, so that will be your visual confirmation, like yes, we found it. Now a real challenge in this is, if you are having a very recent photo, then face recognition base library can do it for you very easily. But the challenge is we are getting photos like those are very old, maybe 15 20 years back, or they are recent but not clear. They are very blurry images. They are having spots on the photographs. Maybe some photographs are taken from the photo, so there is a printed photo or the developed photo. On that they are taking a photo from police station and they're giving to us. So there are some challenges like that. Now if we are using only a face recognition and we are only focusing on the facial points, what we usually see: nose, eyes, forehead, then nose tip, then if we are only focusing on that from ear tip to cheekbone tip, what will be the distance? Then a distance between forehead middle section to the nose point, then eyebrows location and eyebrows distance. So by taking all these extra feeds or the extra information, our parameters are get increased. Because of that we are having a lot of features to check around. So if those are the photos which are blur, but if we can see the distance from cheekbone to ear or forehead to nose tip, then we can plot something and we can identify something. So that was the idea what we taken up, and we took that challenge and somewhat we have succeeded. So this is the code for it. Now you will be thinking like, why I'm showing this code. Are we having any questions? Because I'm not able to see this. Because that is not the entire code what we have implemented, only the glimpse what I have fetched for you. And then I'll be after explanation of the main part, I'll be taking you on the POC application where we have implemented all this, and then I'm running it with the example, the live example. So here, this is the input movie variable where we have captured the video. So maybe that video would be in any format, like it can be MP4, it can be MPEG, or it can be a WAV format, or it can be a OGV. Any format can work. Now, that format we have calculated the length of it. So we created a length, and there we are not actually calculating the length. With the length, we are calculating how many frames are there, because again in order to show that particular person for this POC what it is all about, then we are creating a separate output file. And there we are not focusing on the audio right now, only we are focusing on the video. So we need to repack that particular file with the amendments what we are making, triangle, rectangle, name, everything. And we need to show it as the entire frame or the entire picture. So for that we need to calculate the length, as well as calculate need to calculate the frames, how many frames are there. After that we are creating the output. So for the output, video writer is the function what we have used, and 4cc is what the codec we have used. In that xvid for the um, high resolution images, for that we have created the we have used, we have not created, we have used xvid. And then we packed everything in a separate output file. Now that output can be avi, but it cannot be a same as the input one, because that's the limitation what OpenCV is having. So it can be in AVI, or it can be in MP4, or it can be in any other extension. Then again we need to pack it as the frame is all about, like the 25 frames per second. Then height and width we need to give, so it can be repacked as the original one. If we make any mistake in this, instead of 640, if we write 64, then what will happen, it will not get packed again. You'll see the output file getting generated, but the content will not get appended on it. So we need the exact match. After that, if, we can actually insert almost the infinite number of images, maybe 1,000, 10,000, and maybe more. But and when you are increasing the number of input streams, then the processor and the processing what is required, it is also getting increased. So here we are limiting to the four, so four, at least one, and maximum four, that is the ratio. So at least one need to be given, and maximum four you can upload right now. If we wanted to apply it more, then we can select the images, and we can set a counter for it, and based on that counter we can take the input. That changes we can do. So here we are taking up the four images, or I can take the one of the image. So for this demonstration, I'll be using Badai Ho Films trailer, and in that I'll be identifying hero's face, Anshuman Khurana's face. Now that trailer, if you can look at, then there Anshuman is having movements like at certain moment, Anshuman's face is partly visible, or there is a dark pointers, or there is a darkness behind the person. So there are different scenarios which we can take up as problem statements, and on that problem statement we need to work, or not the problem statement, but we can see the problem or the challenges. We need to overcome that challenge. We need to still need to identify that is the person, because there in a real time that will be the challenge. Like it can be a CCTV footage taken up on a toll plaza. So on that toll plaza, if it is a night, then the visibility is very low, or that camera is faulty, or maybe anything can be wrong, and whatever the footage you are having, that is a faulty footage. Though from that faulty footage we need to identify something. Maybe we can identify a number plate of the particular vehicle, or maybe we can find that person. So that we can do, even we can perform object detection. So so for that we have taken the input here, then that input is stored here, and now we are putting it as a known faces. Now whatever the input we are having, we are considering it as a input, as a raw data, so we are putting it into the known faces. Now we wanted to calculate it. Now once this code is all about that, we are converting that image into RBG frame, and we are plotting a RBG frame on that image itself. So once a frame is identified, like this person or the inputted person is there in that frame, and then we'll create a rectangle on it. Now the caption part. So here we are giving a caption. So if the match one, that is a zero. If the zeroth image got matched, then give a name it as this. If it is got match, second is got matched, give this name. Second, third, and the way the number we wanted to increase. So here are the four, and then we can append the names. So the caption will be appended. And finally, here we are drawing a rectangular. That rectangle will be on the frame, will be from left, and the position will be top. From right, position will be bottom, and this is the orientation of that rectangle. And then font, if you wanted to display that information, then what will be the font for the particular text? That is a font Hershey Duplex, that is a built-in font. uh, then frame the name, and how should that name will be there, and then we need to check the responsiveness. The responsiveness means what? Once that character is moving around or nodding her head, or doing anything like a fight scene or something, or just walking, if we compare it with the CCTV, then that person is walking or driving a vehicle or riding a bike or something, that time still that rectangle needs to follow, and that caption needs to be captured under the rectangle. So it looks like it is following it, but it is actually the frames which are doing that magic. And finally, yes, that is the format, number, length, and we are writing those frames into a final output file. And then when everything is done, then we are releasing that final output file, and we are releasing input file as well, because till the time that output is getting generated, the input file is in buffer. Yeah, thank you. So let's see this in action now. For demonstration, what we are doing is I'm taking the POC. So I have created a user friendly look with the help of Django, and that is the web application what I have created. So this entire track, what here we need to give the name manually, or we need to insert particular image manually. So everything need not to be done manually. So you can have a browse functionality, and where you can browse a particular file and you can put it, but only the frames and height width you need to give manually. So for that, that is already running over here. Yes. So this is the web application. So even I'm having login, logout, and this is the base server based on the Django which is running behind. I have already created my user. It is not having that validations, because this just a POC, and this is just for the demonstration. The actual product what we have created, it is having all the parts on it, validations, then the proper look, orientation, responsiveness, everything is there. But we are interested in how this OpenCV is working, and how the neural network is working to map all these things, because we are taking the triplet, and triplet is the extension of the neural network, or we can say a part of the neural network, where it is capturing the extrafacial points, and then those points are getting referred with the older images. So there are some points, like some points on the face which cannot be changed, though your nose tip or something, after 25 years there is no much change in your face. But still, based on your lifestyle, maybe in a past lifestyle, maybe before marriage you used to be thin, and after marriage you are healthy now. So based on that, your face points get changed. If you are healthy now, then if we compare that photo with your previous photo where you are thin, that time that those normal facial points will not work, because the um, nose tip is broader now, or maybe your chin bones have captured extra healthiness, or so there are different challenges in that case. So that's why we are using a triplet. So here we need to choose a file. So what I'll do is I'll quickly take the downloaded file itself. So I'm having here, this is the video. I'm uploading it. So once I'm clicking on the upload, it will automatically take it on that page. Now here up to 4 image I can give as an input to detect. Now what I'll do is I'll take Anshuman Khurana's image directly from Google. I'll download it from here. Okay. Now you can see the power of AI here, or not the AI actually, the machine learning here. Now I'm taking a very random pick of this actor. maybe this pic. So here, this look what this actor is having, this look is not there in the entire video stream. Whatever the clothes this actor have just wearing in this photo, beard, look, hairstyle, it is not actually same as we can see in that trailer. So this will be a very ideal scenario for us, right? So now this is a .png file. I'm taking this. Uh, Let me just open it first so it is properly visible. No, this is the wrong one. This is for the skin cancer detection scenario. So that case I'll be discussing in meanwhile. Where it is downloaded? Maybe it is in downloads. No, it is not in here. Save it to the location. Yeah. Yes. Now it is properly visible. I'll take this. Now that file is already got uploaded. Now here I'll type name Anshuman. Now here I need to specify the height and the width of that video. So I'll just go to the properties of this file, go to details. Then here this is having a 25 frames as a frame count rate. This is of 25. Height will be 360 and width is 640. Now finally here I need to give my output file name, can be output demo. And then I'll click on OK. Once I'm clicking on OK, it is just confirming it. Once I'm clicking a start, it is starting its processing. Now it is processing depending upon your RAM and your processor. It can take 23 frames per second, or it can take 1 frame as a second, or maybe depending upon your processor, how many cores you are having. So depending upon that there is nothing in the code. So currently it is taking somewhat 10, 15, or maybe a 30 frames per second, because you can see it is directly jumped from 91 to 132. So it is taking that much of one. And if you can take the 4590 are the total frames. So if you remember in this code, let me show you here. If you see, we calculated the length, so we have calculated the frame count. So we need to calculate how many frames are actually there. So 25 frame per second for the complete 2 minutes of video. Then how many frames will be there? So it is calculated in that way. And simultaneously, once each and every frame is getting calculated, simultaneously that image is getting searched in that frame. If the match is found, then it is written, and then that file is again written at the output path. So if you see the output path over here, I have logged in through the direct path, so I can show you from here itself. If I go to media, now this is the output path. This is our output video. Now the main functionality of this is we need not to wait till the entire process is getting finished. We can directly take up whatever the part is finished, and we can see. So it is the simultaneous work which is going on. So if I can directly watch this, you will not hear any audio, as audio stream is disabled. So this is what it have just completed, right? So I think first appearance of Anshuman is at 100 or 300 frames. Yeah, here after this. So if you can see over here, so that is what the actual completed video. This was the completed output, and this is the output what we just created. but if you can see on the 17th second, it is playing. So it will look like this. If you can observe now, if I'm making it on the full screen, now you can see that the quality of this video, purposefully we have downloaded a 240 pixels of video, so which is a very bad quality to view, to just to see whether our case or whether our application is perfectly identifying it or not. And here if you can see that it have identified another person as well. So the name what you are saying, that is totally depending upon us what name we are typing. So this actor's name is Gajanan, so I have taken up a image of Gajanan as well, and simultaneously I have processed both the images. Now if you can see over here at this, is this video visible to all, or it is coming in fractions?
Actually,
I
it's not
paused it now.
moving. Video is not moving actually.
Now I've paused it now. Now
Okay.
it is moving now.
Yeah, yeah, yeah.
Now if you can see that caption is getting flickered. Now why it is getting flickered? Because based on the that character is moving, nodding her heads, or it is having some effects on it. So based on that, that machine is trying to identify all the plots, and it is simultaneously plotting it to capture all the facial points, and again it is cross verifying it with the input, what we have given the input stream. But it is failed here to identify, maybe because of the different factors. Maybe on this my machine is not properly trained, or it is not able to plot, because maybe because of the poor pixel quality. Now you can see it has suddenly got changed from one face to another, and it have identified that too. So you can now see how fast it is. But it has failed here. Still we are improving the quality of it, but still some in some way, if you can say, though there is a dark side, though there is not clear visibility, though it is taking up. Now here it needs to identify it more. Now you can see that was the night situation, though it is taking up. Here also it have identified that person. Some in some frames it have not identified it, maybe a glitch. If you can see here at this point, if you can see, these eyes are not at the camera. Now this is the most important feature what we have inserted here, and that is what our main functionality, that all the face recognitions what we can see, those are focused on the camera viewing angle. So if you are having a camera viewed images or a video, then you can identify a particular face. But here in this stream entirely, no one is looking at the camera. But here is the catch: whatever the input you are giving, 50% at least, it needs to be clearly visible to the camera view angle. So depending upon that, it is plotting a graph. Now if though this actor is looking at someone or to the actress, and it is not focused on the camera, our model is trying to predict that actor, and it is cross referring it with the input image and identifying it and plotting the graph of it, and giving the caption. Even if you can see, here there is a dark side. So here there is absolute no visibility for the cheekbones. So it is calculating from this nose tip to the forehead middle section, what is the distance of it, and based on that it is and other factors, the eyes, eyebrows, this ear to nose tip distance, based on those other factors, it is identifying. I think the current video is also passed to that frame. Now you can see here. It is also, this is the video just we processed. and it is also detecting it, and it yet to process again. Right? Even we tried this with the another videos, and we got a 80% success ratio. Even we tried it with the Super 30 trailer, where if you see the makeup what Ritik Roshan is having, in that Ritik Roshan is totally looking totally different. We are putting a Ritik Roshan's photo from Google, where Ritik Roshan is clearly visible as of Ritik Roshan, and we are processing it against that video stream. Now, why we are taking that video stream? Because that there is a heavy makeup, so those cases can be utilized, or CCTV footages can be utilized in this way. And we, instead of finding the actors, we can actually capture the criminals as well. So this is the first case where you can implement a neural network or deep learning in facial detection, and we can take face detection on the next level, and we can analyze it further. Right. So are we clear till this point? Any doubt on this you wanted to ask? Uh, Shall we take a 2 minutes break? We'll take just a 2 minute break, and then we'll break with the another case study, that is a skin detection, the cancer detection, or the pigmentation detection.
Uh, in meanwhile, if participant have any question, please ask the question, or you can put your question in chat window also. Amey sir, we have one question.
Yes. Shall we use the same technique for any type of problem? Any type of problem is for the face detection you're talking about. If it is a face detection, so yes, you can use triplet for a better way of detecting the face. Even this can be utilized in other areas as well. If you wanted to create a security system or a home automation security system, or you wanted to create any other detection type of a system where you wanted to authenticate a particular user, so there also you can use this method and you can authenticate it. Even you can merge this created technique or the face recognition module with IoT, and there are a lot of ESP boards available where inbuilt camera is fitted or the camera is soldered. One of the board to start with is ESP32 cam. So on that, a built-in face detection feature is available. So you can utilize that there, and you can extend its detection capacity with deep learning and neural network to detect objects to create a object detector kind of that I'm going to show you. So we have created one smart goggle for the blind persons or visually impaired persons who cannot make a proper way around. So that particular goggle is seeing for them. So it what it is capable enough, it is having a camera on it. It is having sensors which can sense the upcoming objects. So if that person is walking on the road, so that is the case study which I'm taking now. So because of your question, it leads to the second case study. So maybe there is a case study like you wanted to create an application where you can use object detection or object identification. Not only detection, you need to identify that object, because object detection is means what you can detect the object, something is there, and you can mark it with the rectangle or to have some kind of visualization on it. But if you wanted to identify it, what that object is, that is a pen, that is a bottle, that is a car, or that is a bus. Maybe that person is walking on the road, and now that person wanted to cross that road. Person without any other's help can cross the road with our device. How exactly it is functioning? I'm not having that device with me as it is in my office, but I'm having a video of it. So I'm playing that. So how exactly this is functioning? It is having a camera. It is having a microcontroller and processor on it. So whatever camera sees, that will be processed on that. Then we have connected it with the mobile application where our machine learning and deep network or the neural network is working, where it is fetching a camera image and the live footage what that camera is seeing, processing it against the available data set. Now that data set we have implemented with the keras and the TensorFlow. So the beauty of TensorFlow, what we can have is we can train our machine learning model for the similar kind of a, object. So if I'm having a bottle as an object, so I can train my model like if you see this kind of a shape, maybe a cylindrical shape or the bottle shape, if you can see that, so you need to identify other shapes like this as a bottle. That is the readiness what we can get in a TensorFlow, and it is a very good framework and the ready APIs to work with. So we have implemented that, so that way our work was reduced to detect the objects. So once we have detected the object, we have identified it, whether it is a bottle, it is just a oxygen cylinder or a fire extinguisher, or what exactly it is. It is a mug or what. So that we achieve. So by looking at that, once that person is moving around, camera is looking at, and the application which is in a person's mobile phone, Android, we just created the Android application. So on that, it is processing and it is detecting it. Now the second part of this detection is that it is detecting from which angle that particular object is coming towards that person. So this thing is helpful for blind ones that blind is walking. So maybe it can be like if that person is walking in the room, our application can detect TV set. So TV set is at 10 feet, 20 feet, 100 feet. So that person is now out of the scope. And if that person is going towards that the TV set, or towards the wall, then it can detect like wall is at 5 feet, and then if it is a close proximity of 5 feet to 3 feet, then it will start beeping. How that person will understand what type of object is there. We implemented a microphone and the speaker, so that person can attach its normal headphones to uh, mobile phone, and because of the properties what we fetch, and we created a properties of microphone and speaker on model itself, and so it is detecting that model and it is alerting through that headsets, so that person can actually hear. Now another part of that is actually the person can hear the distance between that object and the person. again that person can hear that that object is coming from which direction. It is coming from a northeast, it is coming from a north, it is coming from straight upwards, or it is having it is coming at what speed. That is also getting recorded. That speed wala part, we are just working on it. So once that person is walking on the street, and if a car is coming towards that person, then person can identify a car is coming, it is at 100 feet, 20 feet, 5 feet. So if that is the car object, so based on the what object it is, that alert mechanism get it is notified. So if it is a car and if it is coming 60 kilometers per second, then if it is detected 100 feet away, then it automatically alerts that person, you need to go around, or you need to stop, or you need to find a safe place. Why? Because car is coming car is at 100 feet with 80 kilometer per second. So that is the prediction what we able to make. And because of that, it is very useful for these blind persons, or persons like they are having a very weak vicinity and visibility. Or this can be also usable for normal person when we are walking in a very dark areas at the night, maybe for trekking or something. So there also we can, you can identify where is a cliff, where is a climbing section, where is spots or something. Even this can identify stairs. So that is also the challenge once we are working with object identification and these kind of moving object identification. A first channel come towards us, that is we need to identify where there is a staircases or not. If there are the stairs, then if that person is walking on that stairs, each step is of how many inches, or it is a similar stairs or not. So that we need to identify, so that also it is identifying. So that is the case study of it. So I'm having a video of that case study. So let me play that video for you. Um, where it is. Yeah. So yeah, there is a smart goggle. Yeah, so this is the application, the Android application what we made. Once the application is now this video is with the third version of this application. Now we are having almost sixth or seventh version, uh, and still we are improving it. Now you can see once that application is opened up, I've just paused the video. Now it have started plotting, like it have detected something. Now we tested this application with our volunteer, and in a very close and crowded and a very small home. So usually you see lot of stuff in a very small area, and there actually the challenge begins, where our application is properly detecting the things or not. So 60% it have achieved accuracy, because this was on the very initial data set. So that data set was not properly tuned for other objects as well. Now it have successfully detected refrigerator, it have successfully detected suitcases. So if you can see, let me get it back a bit. Now somewhere it is misfiring, as here if you can see, it is saying that person is detected 51%. So this shadow, if you can see it properly, there is a shadow of our cameraman. So it have detected that shadow as a person, but still. But if you can see a bit back, here it is detecting a refrigerator. So you can see that a refrigerator is not having in a full view angle, or in a full camera view angle, though it is capturing it as a refrigerator. Why? Because refrigerator data set we have already created, and we have feeded it as, if we are seeing this kind of structure, then you need to detect it as a refrigerator. So what is a refrigerator, that we have already trained to that model. After that, it is detecting books. Now if you can see here, it is detecting the entire set as a laptop. Now, why it is taking it as a laptop? As I said, we are trained this as, if you see this kind of a structure, then identified it as this one. So there is a laptop structure. We have a flipped laptop, we have opened laptop. So based on that, it have detected it is as a laptop. Though after that, it have corrected itself and it is detecting it as a books. So if you can see here, and the noticeable part over here is it is detecting it in a different color schemes. Now, here is the most critical part where we can say that this is a 80% success. If you can see here by our eyes, we can identify these are the suitcases. But if you suddenly look at this area, you cannot identify that is the suitcase, or that is what exactly it is. Maybe that can be a pillow having some cloths put it over it. Maybe that can be the possibilities. Though based on the data set, it have roll backed it, it have checked it, and then with the neural network inside it, it have detected these are the suitcases. Now how it have detected it? Because of the structure of it, the handle position, the handle way. Now we have given the different types of handles, not related with the suitcase, but in a general, door handle, car handle, suitcase handle, then wire handles. So all those handles we have given it to train. That's why we can say that this is a 60% go, and our machine is learning out of it. Books right now, you can see now here it is book. Now it is self remediating. So if a mistake is happened, like previously it is detected it as a laptop, now it is detecting it as a books. Now why books? Because there are 2 3 books over here laid down. This is the entire box. So it is getting confused because this kind of shape we have not trained that time. And it have confused like this structure can be a laptop structure. That's why it was detecting it as a laptop. Now it have remediated itself and rectified its what we can say mistake, and troubleshoots its algorithm itself. Now actually we are not doing the self troubleshooter, but I'm just taking it as a metaphor that it is troubleshooting it itself. Now if you can see that there is a very uh, s- limited appearance of a water bottles for a fraction of seconds. So there are 2 water bottles available. One is here and second is here. So it is taking that too. So you can see that there are 2 bottles. One is here and one is here. Now if I move this a bit back, now you can see here. So it is taking it that is as a bottle. Here also it is taking it as a bottle, so that is the very much failure we can see. And then if you can see over here, it is detecting it as a remote. So not this entire portion. Remote is here placed over here. So let me get it back a bit. If you can manage to see, here is a small remote. What we have put it, I can see this is a very crowded space, right? There are a lot of objects to detect. So based on the training, so we trained it with the very limited objects like a chair, table, water bottle, suitcase, camera, then books, then after that laptop, some household items like spoon, kitchen accessories, and then the mixer grinder, food processor, washing machine. So the TV unit. So that we use to train it. So that's why it is sometime it is getting confused by looking at that type of structure. Now for this water container, or in Marathi we used to say as a mat. So in this water container, for that it is detecting as a chair. Why? Because it is that water container is having legs, right? So if it is taking up like a legs, now we have improved it. So if there are legs and the flatter surface on that leg, then you need to identify it as a stool or a sitting area. If it is having a proper structure like a chair, then you need to identify it as a chair. If it is a sofa chair, then what type of sofa chair it is? It is a recliner, it is a normal, it is a cushion. So all those uh, things we have already given to it. Now, even if you can see, it is taking a reflection in the mirror and identifying it as a TV. So we have some images of TV from the behind. Back images of the TV we had. So that also it is taking up. Right? So this we can achieve because of the neural networks. Yeah. So how we can use this thing? So one of the area is like we can use for blind persons, or you can use for robots. So we can use this type of object detection mechanisms in robots. So once we are having automated task, or the task given to that robot, maybe to feed medicines to the patients, if we talk about the medical care, or we are having industrial robots to create manufacturing things, or we are having healthcare robots where they are doing surgery. So currently doctors using robotic arms or the small needles of it, or maybe there are different things available nowadays, laparoscopy and all. With the help of these robotic arms, they are performing operations, or they are performing surgeries. So there we can implement these robots having these kind of object detected detection ability and identification ability to detect a particular disease, or the portion where doctor wanted to operate, and doctor can feed like it is a heart surgery and you need to check for the block. Then that robot will automatically checks for the block and gives the solution, like it needs a transplant, it needs another what that the balloon scopy or something. So what kind of situation, depending upon that, what kind of remedy that robo can suggest. So there you can utilize this. So if not looking at the fun part, if you look at this kind of implementation part, then this will be a very good project for your students as well. So you can give this thing as a project to the students, and you can ask students to work on that. So that is what the object detection and identification. So we clear in this, or there are any doubts or the questions to ask? Yeah. Any questions? I will just stop such process.
If you have any question, please ask the question.
I think there are no questions. Okay, so moving towards the next case, what I'm having. So here is the application where we can detect the skin type and different marks on the skin. So this is the test image what I have uploaded. So this is the live application what we have hosted on our application server. So to detect this, we are not using any face recognition tool. We are using Kera's object identification and isolation tools to actually see what kind of structure that particular mark is having, and we are comparing it with the different scenarios, like there can be a skin cancer, or there can be a common skin diseases, or what type of that particular skin is, or whatever the spot is, then it can belongs to what type. It is just a mole, or it is can be a very serious problem. So you can go on skindetect.alcatechnology.net. Alka Technology is another company. So there you can implement. You can see this. No registration will be required for that. Automatically, the model will get registered, and then this image we are using it on the temporary holding basis. So if you're uploading a new image, like if I'm taking an image from Google itself, skin cancer. So if you search skin cancer, then probably we'll get a lot of disturbing images. What I'll do is I'll just take this one. Till for demo and hello, am I audible?
Yes, yes, you're audible. No issue.
Okay. No, there was a message that my connection is unstable. That's why I asked. Okay. So here I have downloaded a one image. So I'll just quickly take this. I think it's downloaded where. Yeah. Now you can see a speed of taking it and the speed of traversing the data. So that is because of the processor what we are having on the cloud, because we are running on the cloud application. So now you can see over here, this is the type, and then it have detected these three things on the percentage level. So you can detect it molecularity and maybe if you see what it is exactly. So it can be available in different types of skin cancers, and if it is a skin cancer, then maybe it is the main part where we can look at. So specifically we have created this application to detect different skin diseases, than marks on the skin, and we are working on it, like we can classify it, like here it is just showing the, sorry, yeah, where it is, yes. So here it is only showing, my screen is visible or it is stopped one.
No, it's not visible actually.
Now it is. I mistakenly clicked on stop
No.
share.
Yeah, now it is visible.
So this is actually taking up the photograph of the affected skin area, and it is only taking up with these three categories as we have mentioned it into our dataset, training dataset. Still, this application is in the beta process, so maybe in a month or 2 month we will be finishing it up. So we are creating a database. Like once we have detected a particular skin type, then we can suggest a remedial solution, or we can suggest a nearest dermatologist who are expert in that kind of a disease, or what you need to do, or what will be the possible treatment. That all information we are now implementing on it, because this is the live project what we are doing with the one of the healthcare institute, and they actually come to us for this kind of solution, that if we are having this kind of so implementation, then how exactly we can identify it. So we suggested that with the help of machine learning you can identify. So this particular application or the similar applications like this, or on the base idea, if you create for respiratory diseases, or you create for any kind of other diseases. So instead of just getting the picture, or instead of getting it, if you created a device which can be wearable or something, so there you can identify these diseases much earlier than it is appearing. Or if there are some signs, like we are having a cold, so we already have signs like we are having a difficulty to breathe, and those symptoms we are are having, so we can prepare our mind. Okay, I'll be having a cold in next 2 to 3 days. So that kind of a prediction we wanted to create in healthcare, that by looking at the particular problem, we can predict, our machine can predict in future what can be the worst scenario, what will be the treatment for now, and you are at what stage. So if it is a skin cancer, or then we can detect that this is at the first stage, this is on the second, or this is beyond repair. So that way we can identify it on the machine level. But still, for the authentication of the particular data or integrity of the data, we need to take a consultation of medical field expert or the SMEs from that field, or the doctors, for improving this data set. But still, this work is in process. So like this, you can implement a lot of things on it. Now, further thing, which is taking us in a complete neural network with the code. I'm just demonstrating you the stock market prediction. So it is not a very new area where we are doing anything. We are not having any project on it. We just borrowed some code from Google itself for this demonstration, for discussing the case. So maybe there is a scenario like I'm a stockbroker agent, or my company is dealing into stocks, or having a trading, and I wanted to predict whether whatever the stocks I'm dealing with will have a profit in future or not, or what type of stock I need to purchase, or how exactly I need to guide my customers to go and invest something. And if I can get that kind of prediction in beforehand, then I can be making up good profit. So here it is. I have created a notebook file. So let me open this for you. Yep, sorry. Maybe the session is expired. The Jupyter session is expired. Let me refresh it. Okay, this file is already opened here, so I'll just explain you from here. So what we are doing here is we are coding it into a Python, and to start before with that, what we are doing here, we are importing some libraries, NumPy, Matplot, pandas, and datetime. So what NumPy will do, NumPy will give us uh, accessibility to work with the mathematical functions and manipulation of those functionalities, and you can actually use into a multi-dimensional arrays. So for a statistical implementation, NumPy is very important. After that, we required a data visualization tool. For that, we are using a matplot library for data visualization and data manipulation. Then we are having pandas. Now, pandas libraries is very important once we are dealing with the variety of time scale data. Then panda will give us a data analysis and data manipulation kind of a functionality. So panda library is important in that case. And then we are using date time library for capturing for timestamps. Now, here, to have a prediction, we need to train our model, right? So we are training our model with the available stock prices. So here we are taking a stock price. Now this model, for the purpose of this model, we have taken up a stock prices from 2012. So if I can show you that data set. So this is the data set what we are looking at. So this is the data set where we are having a date, we are having open, high, low, close, and volume. These are the main objects what we will be processing. So open is what, at which point the Sensex got opened, at which point it was high, it was low, it was closed, and at what value it got closed. So this is what the history we are seeing from 2012 to I think 2017 we are having. So this is almost 1259 data entries up to 2016. We are having the data entries. And if you can see this data or the data set, what we have created. So in this, there are no faulty data as such, or there are no null data. So once we are having a clean data set, then it is very easy for us to be processing with it. Otherwise we need to cleansing the data, so we need to check for the possible errors, check for the null values, we need to check for the negative entries, then we need to check for the no entries. So all those we can check. Even we can check it with the function. We can use the not applicable function to see that what there are any point in the data set which are not applicable for us, and if it is there, then we need to rectify it. So I have uploaded that in my Jupyter notebook, and I'm fetching it from that itself, and I'm reading that CSV file. So this is what our raw data is. If you see the head means what the this function will give you some entries from top. If I use tell, then you will get some entries from bottom. Right. So here it will not function as it is not connected. It is trying to connect. Yeah, it is not displaying anything by because it is not connected to it, and it will take some time to get connected because that session is already expired. Maybe after some time it tries to re-establish the session. So the information what you were seeing, so that is from the head. So the first top some data you will be seeing. Now if it is getting presented, then it will be from the bottom. Then here we are checking whether there are any possible loop backs or any possible zero entries or any negative entries are there, means the not applicable data is not applicable. And if it gives us a boolean value, and these are the parameters: open, high, low, close, volume, and all parameters are having false valuation, it means that there are none not applicable values. Means what, your data is proper and your data is not having any loopholes in it. So if one of the parameter is comes true, that means that that particular parameter or that particular object and the data inside it having at some rows it is having problem. So there we need to check it. After that we are just taking up the information of that data set. We are taking the date indices of it, how many entries are there, when the data set got created, from which date to which date there is a data set. So that we are taking, and of course the data type of each and every object. So if you can see over here, the data type is float for till the low object, and then another data type is object. So we need to convert all the non-associated object type into the associated object type, so in order to process it properly. So either we convert all into the objects or all into the float, so making it into the float, which is a more feasible valuation. So for that, here we are running that function, and before doing that we are just plotting a graph. So this is the graph, because I actually we need to convert it first and then we need to put the graph. Though it will not make any difference, the graph is the graph talking about from 2012 to 2017. This is the stock market ratio of the Google. So we taken up the Google ratios, Google stock market prices. So of course it is the Google, and it is having a very popular engine in social media. It is having good shares. But again, share market is totally different, totally depend, and it is totally depend on the different things. But still, right now for our demonstration, it is talking about the profit way. It is having a upward graph. Then here we are converting. close and volume data entries into a float. And after that, we are taking a 7-day rolling mean. Now what is a 7-day rolling mean? That now we wanted to predict, right? In near future, if I go and buy Google share, then I'll be in a profit or I'll be in a loss. So for that, the way to predict is we can check the history and we can analyze it, and we can make the impression of it, right? So here we are taking a 7 days rolling mean. So it means what? We are taking a first 7 days information, uh, processing it, and then we are predicting it on the we are taking the mean of 7 days, and we are processing it, and we are predicting it on the next available day. So here, for example, if we are taking the 60 days information, then we are processing the 60 days. For example, we are processing the 60 days, and the prediction we are doing for the 61st day. So that way, if we wanted to process for the predict for the 62nd day or the 62nd day or 63rd day, then what we need to do is, if it is for the 62nd, then we need to start from second to 61. Then we'll have a 62nd days presentation. Same with the other days. So that we are doing. If we are having any questions? Okay, feedback. After doing that, here we are, what we are doing is we are plotting our prediction graph. So if you can see over here, so this was the prediction. This was the original graph of the data set of the Google, and this is the prediction graph. Similarly, clearly you can see that here from it is going similarly. Here it is somewhat different. Then we observed a downfall here, and then it is going up again. So if you can now see, by looking at the history and by looking at the previous pricing, we can predict that in near future, and by looking at the time gaps, the traversing and traversing, we can predict that in near future you can be in profit by looking at this. But still we yet to come on the prediction part. Now here we need to take the closing day. So we are starting with the day, and we are taking up the closing day, and then again we are plotting it. So it looks similar, it needs to look similar. And this is the thing where we are specifying the minimum number of periods. So this is what this is the these are the periods where we need to look back, check it, predict, look back, check it, and predict. So that is what the back propagation is called about. So that back propagation we are doing on the minimum period number over here. And this is the graph what we have plotted. Now here we need to create a data frame on which we can train our data set. So by doing all the above part, we have created a data frame, and now we are training our model. Now to scale it for future detection, we are using min max scaler, which is coming with the scikit-learn library. Even scikit-learn you have already using, or sklearn you are using. It is a very good repository of the machine learning algorithms and the predefined procedures for it. So we have borrowed it. So from the sklearn we are creating a minimum access scaler, and we are transforming it. So we are creating a transformers on the training data set. So by that, now we are plotting X train and the Y train graph, and on this we are creating a shape. So here on the X train, that is what the data set was. On that we have trained our model, and from the Y train, which is a predictive model what we have created, and the data which is accumulated on that, from that also we have trained our model. Now we need to create a recurrent neural network to do the prediction. This example is all about recurrent neural networks and LSTM. That is what the long short term memory, where we need to store it, that we already we had to discuss it. in Saturday's session that we missed the 2 days back session because of the power down. I not able to complete that session, so I'm taking it on a Saturday. So on that, we'll see LSTM and other memory functions. So this requires a recurrent neural network and LSTM to function. So to have it, we are using it with the Keras. So Keras models and the layers are properly built with the framework libraries which can be used for differential neural network or the deep dive neural networks. So here we are using Keras model. We are using a sequential model because the information what we are having, that information is a sequential information, which is a linear stack of the layer, and it can throw a sequent model by passing the list, or it can create the take the model and passing the list for the manipulation. Then we are creating a dense layer. Now what dense layer is? It is a regular deeply connected neural network layer. So this deeply connected neural network layer is here to change the dimensions of your output vector. Now why we need to create we need to change the dimension based on the input cycle and whatever the prediction you want. So by that, if you wanted to do the manipulation, then you can use the dense layers. Then of course we will be having a long short term memory, and then dropout. Now what exactly dropout function is? It is somewhat a cleansing function, which is regularizing your techniques, and it is visualizing, and it is reducing the overwriting and overfitting in the neural network. So that is what the dropout is. For these kind of time related or the timely related problems, we generally use regression. So here we are using a recurrent network with the sequential regressor. So we have created a model regressor, and we have passed it with the sequential one. Now here we are having here we are having a four input shapes and the input streams. So here it is your training data, and the dropout is actually cleansing the data set, and these are the three layers. Like the first one is your LSTM, then we can have a sequential analysis, then the other analysis on it, and then finally we can have the epochs. Now what exactly epochs is? It is a frame of the machine learning indices. So this having this created by the passing the entire ML processes. So that is the epochs. So 100 epochs, the limit we have given. Then it is associated with the batch size. So now the batch size is what it is, indices of the total number of the trainings, what your example have utilized. So that is what the batch size is all about. So by looking at this, you can see these are the steps. So in a very normal way, you can see that epoch is a step, and or the recurrence step, and batch size is what the total number of the trainings you need to do on that particular batch. So that is the batch size. And finally here you need to test it with the actual value. So by having till this line, your machine is getting trained to understand the history or the historical trend of that particular stock company. So maybe we are talking about the Google. So how Google have performed in the past. So if that information is already understood by your machine, then based on that understanding, machine can imagine, or not machine cannot imagine, but machine can predict in a future you will be in a profit when you buy a Google share, or you get a loss by buying it. So for that we need to create a test scenario. So everything is the same, like we have created a test CSV file. Even pandas is also used as it can be taken up your files as a CSV or Excel or SQL files, and it can create Python objects which can be seen as what we can say a table in a mathematical function like this you can see. So here also we have used this, and then we have put it the real stock prices. So those are the prices right currently we are having. Even we are passing it with the head, so everything is same. Then again here we are just printing out the information of the data set. Here is the object type, other are the floats, so we need to convert it, so we are converting over here. And after that we are plotting a graph. We are again checking the information against it, and now here we are analyzing the test and the train data, and whatever the information we will be getting as a result of that analysis, that is our prediction. So finally over here you can see the final Google price stocking, and you can see that the blue lines, if you can follow, those are the predicted Google stock prices, and the reds are the real ones. So the one we give it or the given it as a training data set, so those are the real data set, and blue is the predicted one. So it is also by looking at the real data set and the events what it is there, it is predicting that in future also Google stock prices will be in a much better shape, so you can buy it, you will be having a profit. So similar case you can use with the retail industry for detecting whether a particular product will give you a profit, or it will take you on the loss. So that this way you can use recurrent neural networks to analyze the feeds, analyze the incoming feeds, and can process with the information and can predict the future what we can say future objectives, like you need to predict with the profit, or you need to analyze the star maps. If we talk about the space exploration, then we can use neural networks and deeply connected neural networks to create a map of a universe. So that project is already going on at the various level from the various governments. So um, yeah, so this is, I think this is for the day. If you're having any questions, please ask. We are open for question and answers. All these material I'll be sharing with sir and ma'am, so they can share with you.
Participant, if you have any question, please go ahead with the question. I think participant have understood everything. There are no questions.
Okay.
Yeah. So participant, there is one announcement for you all people. So there would be one test on Saturday. Test will be based on whatever the topic was covered by the all speakers throughout this FDP from 23rd to 5th of December. Upcoming 5th of December. That all will be the syllabus of that question value of the test. Okay, so be prepared for that test. So it will be on Saturday after the morning session of again of Mr. Amey Tambe sir. After there will be the uh, test. Okay, so there are no questions. So
Yeah, so thank you very much, participants, for listening me very patiently and understanding what I am just trying to convey with you. If you are having any questions later on as well, you can pass it through me on my WhatsApp, or you can pass it to the FTP coordinators, so they can pass it to me. I'll try my level best to answer all the questions or all the queries. Or in future, if you require my help, then definitely I'll be leaving my contact information on Saturday, so you can contact me anytime for any kind of a help. So thank you very much. Pleasure to
Yes, thank you
delivering the
very much
session.
to you, sir. Yeah, thanks to you for sparing your time for this very informative session, and also thanks to all participants for their contribution. So hereby I declare session is over.
Yeah, thank you, sir.
Thank you. Yeah.
Okay, thank you, sir.